On June 8th, James Scheer described monitoring equipment now in place on the Hood River Bridge. This equipment will gather baseline data about how the bridge moves and reacts to weather and winds. It will also provide data as the team moves on to driving test piles at a few spots in the water. A few terms to know. Piles are steel or concrete columns driven deep into bedrock to support the loads coming from the bridge. They're not visible to us, they're below the water line. The piers are the concrete structures we see going from the bridge superstructure down into the water.
And knowledge, I kind of wanted to open up and show a little bit more behind the curtain of what's going on in this monitoring program. So, first thing I wanted to do is why we're doing what we're doing. So, this is the geotechnical profile from 2023. So this is kind of current data. We've been out there doing some borings over the past 6 months that's refreshed this data. But what we found is that, I'm going to go zoom into this area here. What we found, and most people in this room know this, but this is just a visual representation of what's going on out there. The existing bridge, this is Pier 10, 11, 12, 13. There's portions of the existing bridge that are pile founded, that are on beds of gravel and or in sand, that when they were installed in the 20s and 30s, they are not touching bedrock. So what you're seeing here is this red dotted line is where they thought bedrock was way back when. They drove pile that touched those locations, and then, but in reality, they're not on bedrock, which you can see here in the dark gray. And then there are some, as you get closer to the Washington side, there are portions of the bridge that are founded directly on the bedrock. And so this is just an example here of what we have from 2026, exactly where the bridge is going to go. We've went into each shaft location and drilled a hole, and we just completed that last week. We've drilled a hole in each shaft location to find out exactly where bedrock is and what's the quality of the rock in those locations. So I'm not going to get into a lot of any detail on this, but the bridge monitoring program is kind of hand in hand with the test pile program that we're going to want to do this next in-water work window. And currently, when we start talking about the test pile program, there's basically 4 locations and about 4 pile that we want to install in each of those locations. And this has been like this ongoing discussion that since Kiewit's gotten on board with the authority, just talking about how we're going to monitor the existing bridge and what kinds of checks and balances, so to speak, we're going to have to make sure that we don't do any harm to the existing bridge. There are some past examples of where things have not went very well on different jobs. This is a job in Iowa over the Mississippi River, where they started driving pile next to an existing bridge, and the existing bridge started to move too much. This is another example from one of the SMEs on the project of where they had to go and install angle iron and stuff to help shore up the bridge. And that's just where we're trying to be proactive on this and get ahead of it.
Do you have solid data that shows the actual depth of the current bridge piers?
Well, it's data from when the bridge piers were constructed, and so it's data from the 20s and 30s. So, some of the data that we have, Jake, is off of a drawing that says install pile, 25 feet below, blah blah blah, and then to what the requirements were for proofing the pile. So there is some as built information there, but it's only as accurate as we want to assume it is from archived information. So Next, I want to talk about the actual bridge monitoring. There's different components of the bridge monitoring, and I'll walk through what those all are. But the objective, as Mike kind of talked about earlier in this meeting, is to develop a baseline of how the bridge moves under normal circumstances, and that way we can compare that circumstances to compare to during construction operations. This is an example of some of the drawings that we have. This is the level of detail that we have, and so there are 20 piers on the bridge. This is the Oregon side as it works across to the Washington side. This is after the lift span has been installed. That's what we're working with. This is what it looks like. We have a rope access team when they're actually out there installing the different sensors on the piers. And so, getting to these locations is not necessarily easy. And I special thanks to the Port of Hood River letting us get up on the bridge and do this work. This is the same rope access team that the Port of Hood River uses to do their inspections and that sort of stuff. So they're very familiar with how to get to the different spots on the bridge. Now I'm going to walk through um, the various sensors that we have. So first up is some tilt sensors. When we install them, you can see here there's two separate tilt sensors on the bridge. This is it located. One is oriented, with the direction of traffic on the bridge, and the other one is perpendicular to traffic on the bridge, so we can tell if the pier is tilting one way or the other. The next thing that is up there is the vibration sensors that measures the vibration in the bridge in what do we figure, Mike? Is it's inches per second?
Yeah.
And that's the standard that vibration and that acceleration is measured. These boxes don't have internal batteries. They're powered by a battery that's installed on the bridge, and then there's a solar panel that's charging those batteries to keep them charged. The next thing that we have out there is survey monitoring equipment. So we installed for primary control, we set up two total stations, which is a survey instrument, one on Mount Adams, or the top of Mount Adams Fruit, and then another one in the SDS yard. And those have the ability to see the bridge and see prisms that are mounted on the bridge. I'll show you a photo of that here in a second. But on the left, that's an example of what's up on top of Mount Adams Fruit. And you can see, I mean, it way off in the distance, it's a long ways away, but the survey instrument's powerful enough to survey those. And then the piers of the bridge move a little bit. And so in order for this survey instrument to like understand and be able to have fixity for itself and understand where it is in relationship to the world and verify that it's not moving, we have a series of back sites, we call them, but they're just really fixed sites out there that the instrument is checking the location on and closing the loop, so to speak. So this is one of the automated survey instruments that we have. The other one is at SDS. Here's an example of what the prisms look like on the actual piers of the bridge. They're mounted on the bridge, and the total stations can see those. Here's another example of a back site up on the side of White Salmon on the side of the hill there. Just as a note, one of the troubleshooting things that we've found is that you can see both of these prisms are directed towards Mount Adams and the SDS lumber survey instruments. Those survey instruments being robotic are not, they were not able, because the minute of angle between these two prisms, the minute of angle is so slight that the robot is not quite able to just always fixate on one of these prisms. So what we did is we turned one of the prisms towards the Best Western on the Oregon side, and then one of the prisms we verified can be seen by both Mount Adams and the SDS unit. So what that allows us to do is, if we have the need or want, um, we can set up a temporary total station down on the shoreline, on the Oregon shoreline, and we can shoot the piers from there. And this is an example. An example of when we might want to do something like that would be during the actual pile driving process. When we're installing pile, we could be shooting from Mount Adams and SDS and here. And there's another option if we want to go out on the point, and we could put survey prisms on the other side on specific locations if we wanted to take shots there.
I have a couple questions. Did you what did you consider putting like any sensors near the base of the piers, like actually in the sediment to record movement at that location?
No, we figured that any movement at the base of the piers would translate up to the top of the piers.
So James, I have a question, and all of the sensors are working to give a full awareness of the entire bridge.
No, and I'll show you which ones are working and which ones that we're still having difficulty with here in a second. Got a little graphic on that. I'm going to move on to the air gap monitor and go through that, and then Catherine, I'll hit your question directly. So the air gap monitor, or the tide sensor, it's really a measurement to tell us where the water level is. So this is a photo of what it looks like on our bridge. It's located at the base of the stairs that go up to the control station. So it's located in this area off of that platform. What we were told is that all of this would work, and we were told that by the people that make the communication tools. Come to find out, it doesn't. So what we've updated the plan is we're going to go to a cellular transmitter that's going to transmit information from the air gap monitor directly via cellular network, and we think that that's going to be a lot more reliable. The last sensor that we have out there is we have a weather station up on top of the tower. Here's an example of this is some of the rainfall gauges, information that's coming in. This is wind and temperature data that's coming in. And so all of that data is being collected and stored on the server. As all of this is transmitting through a Trimble 4D control system, so it's all being captured in real time, and it lines up, timing wise with different things. So this is the um, the web page that we can go to, the dashboard, so to speak. And then like this is the level of detail of information that we're getting. I pulled up Pier 3 for the April to mid-May. And so this is the level of information that we're getting for the piers for the vibration sensors. This is the level of detail for the tilt sensors in the east direction, and then the south direction that we're getting for the tilt sensors. So we just selected 3 different piers out there to put in this presentation, and make sure everybody's aware that this information is coming in. And then to answer your question directly, what I did is I made up this kind of a heat map, Catherine. And so this is Pier 1, Pier 2, Pier 3. So I added all of the piers across to Pier 20. And so all of the tilt sensors are in and reporting data. The vibration sensors, as Mike alluded to earlier in the meeting, we have two of them that are not functioning and not transmitting data, but the other 18 are. The survey monitoring on from the east side, the which would be Mount Adams and and from SDS, just because of the trees and things, they can't quite see the prisms on Pier 19 and 20. But if we're monitoring that from the best western side, we can get a lock on those. And then the last thing is the tide sensor, and I probably should just pull that down to um, one of these squares, but the tide sensor being over the navigation channel, it's gathering data. It just can't transmit the data right now, and we got to get that fixed. And the weather station is working.
And James, just for everybody's, the east side and west side are kind of a redundancy system, right?
Yes. Of the survey, yeah.
Yeah. So the fact that we don't have those two is just we don't have the redundancy at those two locations. But over all the rest of them, we've got redundancy. Still have data. Still have data. We're still collecting it. We just don't have the backup for those two because of the trees, and we weren't allowed to go cut them. So
Where are there's specific piers that are not in bedrock. Can you show us on that map? I'm just seeing if it's where we don't have full green picture, James.
The piers that are not in bedrock are from here, it's either 16 or 17, somewhere in there. Let me go back up and look. It was on that map. Oh, wrong way. So Pier 13 to the north, it appears as though those are in bedrock. There might be a couple around that's 13, 14. There's a couple in there that might not be on bedrock, but the last two I think are.
primarily it's that yellow area, Catherine, that you see that they're not on bedrock.
Everything from like Pier 2 to
It's about Pier 3 to 12 roughly is not on.
Have we learned anything from the monitoring we've been doing? I mean, do we have comparison that we can say this bridge moves a lot or doesn't move a lot, or is that not meaningful?
That's what we're looking at now is to establish a baseline for the bridge.
Mhm.
So now that we've got everything kind of functioning and we've collected data for a few months, that's the next step is to really get in and normalize that, put some statistics to the numbers that we have and figure out what our average is and our means are and what's the deviations. And that's what we want to do next. And then take that and look at it compared to whatever criteria is out there for allowable movements and see where we are.
Gotcha.
The other thing that I wanted to bring up, I meant to bring it up a little earlier, is that, this was a discussion that started like in the phase 1A timeframe. And we did this investigation of what types of instruments and stuff we could put on. We were able to, as a team, we were able to not have to spend any more budget than was already allowed for phase 1A to do all of this work. So this was not part of the original scope of phase 1A, but it was able to be added into the scope of phase 1A at no additional cost. So this is really kind of a success story to be able to have this as part of the program thus far.
Kevin, it looks like you have a question.
Well, it's not so much a question, just maybe, I don't know, words of wisdom. Having managed the bridge for a few years, we do see slight structural changes to the bridge during very hot periods. And so we do see minor fluctuations during very, very hot temperatures and very, very cold temperatures. And so I think any baseline, at least would be my recommendation, that would cover both of those types of scenarios.
Yeah, and that's the reasoning behind trying to get this on the bridge early, is to be able to see how the wind affects it, how the temperature affects it. Because I expect that when the temperature gets hot, it's going to expand, and there's going to be different movements on the bridge.
James, can you speak to, I'm sure that this is kind of one of those questions that are really, I'm sure is going to be nearly impossible to answer, but just for like somebody that's never been through this type of scenario, as we're looking at doing this style program, can you provide just even like an anecdotal explanation of how doing this test pile program early could save us significantly to find out that the bridge is going to move, more than is appropriate under driving the test piles than if we waited until, we have the construction equipment out and are needing to drive the test piles anyways?
Yeah, I guess the best way to describe it right now, Ben, is that if we go out there this first in-water work window and drive some pile, and we're going out there with a kind of a minimum amount of personnel, a minimum amount of equipment, and it gives us the opportunity to kind of test a few things out, and you don't have everything else in the world waiting on you to go. So if it takes us an extra couple of days to do this test pile program and learn a few things, I think that's very beneficial versus going out there during construction and you have the entire equipment fleet there. It could get really expensive really quickly if there were delays.
James, do you have a rough per day cost that you'll be looking at when you get the construction, or what you've seen on other jobs?
I mean, what I've seen on other jobs is it's in the hundreds of thousands of dollars a day, somewhere between, I'd say, $150,000 to $300,000 a day is what I've seen on other large projects.
We'd have a per day cost of that for them to sit and figure this out.
Okay.
At least that much.
That's all. So it's less about like being able to have, coming up with a better design than we otherwise would have, than more just minimizing construction delays.
Well, just more
Risk mitigation.
Yeah, it's risk mitigation to know whether or not we would have an issue so that we could redesign if we found out. If we get out there and drive the first pile when the bridge starts to move, hopefully it doesn't move too much, we would have to figure out how to protect the existing bridge from that, right? And we would want to do that now rather than having, $300,000 worth of equipment sitting out there every day not doing anything.
Yeah, the other thing to be aware of, Ben, is that we're doing this work, this critical work inside of the in-water work window, which is 160 days of the year, between October and March. And so if you do have a delay in there, you're also kind of wasting that time that you are able to work in the water. And as soon as the end date hits, then you have to stop no matter what. So it allows us to do that ahead of time and then gives us some breathing room maybe to come up with solutions if we need them.
The other thing that we'll get out of it is some environmental information about how maybe some of the protection stuff works, but also production rates potentially of how long it takes to drive something, or how hard the material is, how much problems does it really have getting through certain materials. So it'll give us some construction scheduling and productivity information as well.
Are we able to access this document?
You will be, the document or the data?
The presentation.
Yeah, we can get it on SharePoint somewhere.
I was just wondering if you, from the weather data, if you're seeing if it matches up with what was on the Oregon side and what we had access to before. I guess my concern is going to be those winds and your ability to fly steel in and what that looks like so far. Have you been able to review any of that data?
We have not reviewed any of that data and matched it up with anything yet.
Does the water level impact pile driving, and would it be worth reaching out to the Army Corps about either raising or lowering the water level to mitigate impact to the current bridge?
So, the water level doesn't necessarily have an effect on the pile driving. We thought that the water level may affect how the bridge moves, and it also is a good indication for us to determine like how much draft we're going to have in different locations on the bridge, especially like on the Washington side, to see if there was a fluctuation in that over time. Right now, we're not seeing a very large fluctuation in the water level for the data that we've seen. And then to answer your other question, Jake, like we have for the geotechnical borings, there was an opportunity for us to do some borings closer to the Washington shore, but we couldn't get in there because the water was too low. And so we were able to talk with people down at Bonneville and get them to temporarily hold back a little bit more water and fill up the pool and get us an extra foot or so of draft. And then we could move the barge in as for like a day or two for drilling. And then they lowered the water level.
Hey, James, I just had a quick question for you. You showed a few charts that we are able to access via webpage and whatnot. We're able to pull the raw data from the sensors as well, right? Not just have pre-populated charts, but actually have the raw data off of these sensors so we can create our own data or display our own data, correct?
I don't know the answer to that, Grant. I would assume yes, but I can get back with you on that.
Yeah, if you can give us a definite answer on that, because that way, if we have the raw data, then we can create our own charts or any
Yeah.
actual data analysis that we or anyone else may need, since we'll have the actual data and information using these sensors. That'd be great.
Yep.
Thanks.
And one thing I would say within the next month or so, we'll be coming back kind of with the data and what's available to you. And for you all to think about how you want to share or what you want to share. I don't know that anybody can do anything really with it. It'll tell you, well, the bridge moved this much or did this much. That's all it's really going to tell you. Because there's nothing in there that says, here's an alarm bell or, here's a critical thing. But if somebody wants to just go see a bunch of data or, they can. I don't know if there's anything harmful in that people see it. Yeah. So, I think with that though, with data becomes the risk of somebody doing their own analysis without the backup and inferring things or developing things and putting them out there and saying things that maybe are not factual. So that's the only part that you need to take into account is,
I mean, I'd be interested to know, like, does the public have access to similar data on the Golden Gate Bridge or the Brooklyn Bridge? For that reason, is uncontextualized data making it available to the public, is that actually a thing that serves public interest, given what you just said?
We could look into that and see what other bridges do. They're collecting data.
I'd like to know that.
Yeah, I don't know. Kevin Greenwood, do you know if, or Dan, you might know too, is Cascades, I know they're monitoring their bridge. Are they putting their data out?
They are monitoring. I don't believe it's public.
Yeah.
I can confirm that though.
Some of it becomes a little bit of a security issue, right? That do you really want to put out publicly a weak spot and have somebody, you just don't know what people might do. So there's somewhat of a security risk of it.
I'm hoping before we get too far into that discussion, we are able to have some real open discussions with the port and their engineer of record for the existing bridge, and just kind of have a pretty good open discussion about what we have, how we're going to use it, what are the engineers that have been managing the bridge currently think it's telling us, and
we've got a plan to meet with the port GECs and go through some of that with them once we get a chance to now digest some of this data and start to do that. So
Yeah, I mean,
Yeah.
it does seem like court should sign off on whatever the data, if there is data sharing that they have a chance to give input on that.
Yeah, and it's really their bridge that we're putting data out on.
For context, I can imagine use for our own or the port's internal use, even before it would even go out for public consumption, exclusive to our own use. So there's two sides to this whole thing. So before we even delve into making this available to public, I can imagine a lot of internal uses for this data, should we even have access to it. The first answer is, can we even get this data? And that's the question I had for James, is can we even get access to the raw data first? So before we answer the second question, we have to answer the first one.